Hello, this is Ray Marquiss, Senior Application Engineer with Valin Corporation, and this video is going to demonstrate how to exchange information between the safety PLC and the control PLC using exposed variables. So let's get started on that. Before we get started, I made this graphic to help explain what it is that we do when we expose variables or when we use the variables inside the safety PLC. On the safety PLC, not necessarily connected to it, but on your safety PLC system, which means the safety PLC controller plus any safety inputs and safety output slices that you've got added to the system. You will have safety inputs, of course, and safety outputs. Those are real physical safety inputs and outputs. In order to use those in your safety PLC, you'll have to create variables for them, and then you'll use those variables in your program. At the same time, these safety inputs and safety outputs are exposed to the I/O map of the control PLC, and you'll see them in the I/O table. I'll show you that in a little bit, but you also create variables for them in the control PLC so that you can use those objects in your control PLC as a way to monitor what's going on with your safety PLC. So in other words, we could have an E-stop physically connected to the safety input. We give it a variable name called E-stop in the safety PLC. And then when we look at the I/O map in the control PLC, there will also be a I/O data object that says it's the safety input 0, for instance, or safety input 1, or whatever it is that you've got, and whatever your E-stop is attached to. Then you would create a variable for that object called E-stop. So now, or you could call it safety PLC E-stop, or you could call it dog, whatever you want to call it, doesn't matter. And then whenever the safety PLC E-stop input is activated, you'd be able to see it over in the control PLC on that variable that you created for this object. Note that all of these safety input and safety outputs, even when you create variables for them in the control PLC, they're not available for writing to the safety PLC. So you can monitor them, but you can't write them. They're read-only. Now, there are variables called exposed variables. You can expose inputs and you can expose outputs. When you expose those, you do the same thing. You basically create a variable, but there's no physical object associated with those variables. Once you expose them, they become available in the I/O table for the control PLC as an object. When you create a variable in the control PLC for that object, you can monitor, and in the case of the exposed inputs, you can actually write to them. So the exposed inputs, in this case, I could write from the control PLC to the safety PLC and actually have the control PLC turn on this variable inside the safety PLC. So that could be used for non-safety functions like selecting a mode or a reset for a safety function. Anything that's not a safety doesn't require a safety data type. And then down at the bottom, there's a graphic that just shows that you'd use these objects and variables in your control PLC ladder program, and you'd use these objects and variables in the safety PLC program. Next, we're going to get started with this Sysmax Studio software to see how you actually do this. Okay, if you've been following along with the previous videos, then you'll have a project similar to this set up already. It might not look exactly like this, but you'll have a project in Sysmax Studio that has a control PLC and a safety PLC added with some safety inputs and safety outputs. You don't have to have this view open right now. In fact, I'll just close it for now. And what we're going to do to start with is we're going to go under the configuration and setup information for the safety PLC and go underneath that and scroll down until we get to the exposed variables. So you might have to open a few of these or unpack a few of these options, but we'll get to exposed variables and double click on that. And this is where I create these variables and expose them to the control PLC. So I'll right click in this output area and I'll just click on create new. Then I can give it a name, and this is an output, so this goes from the safety CPU to the control CPU. So let's start the name with a lowercase s PLC, so we know that's where it came from or what it's for. And then we'll call this, let's see, this is an output from the safety. So we want this to tell us if the E-stop circuit is okay. So we'll say E-stop okay. And then it's gonna, it takes a little bit of time because it does a lot more than just create this variable in one place. So you'll see that in a minute. But then you can select the data type that you want it to be, and I've selected it to be a bool. There are several data types available. Here are the ones that you can use for these exposed variables: a bool, a byte, a dint, an int, or a word. And then I'm going to go down here to the input side. This is from the control PLC to the safety PLC, and I'll create a new variable, and we'll call it CPLC, control PLC, reset. Simple. And it'll automatically be made a bool. If I wanted to change that data type, I just click in there and start typing. I could type int or whatever, but we'll just leave it a bool. Okay, now I'll go ahead and just keep going with the safety PLC. I've got these, and I know that they're going to be controlled and monitored by the control PLC. So now I'm going to open up my program underneath the programming section, double click on the program here. And right now I just have the, I would normally have started here with the reset switch, which is a real physical reset switch on the safety controller. But what I'm going to do instead, I'm going to go up here and I'm going to create a new rung above this. So I'll right click in this pink space and say insert network above. I'm going to use a Boolean operator function block, which is an OR. You can see some others here that you might want to play with later. But I'll grab that OR, drag it over to where it says start here because I'm a rule follower. And then right here, I'm going to put that reset switch. So I'll say reset switch 01. That's the real physical reset. And then here, I'm going to do that CPLC reset. So that's coming from the control PLC. So now I've got an OR for either the physical switch or the control PLC switch. And then in order to turn on something, I'm going to go to, it's a little tricky, but you got to click right on that little nub that comes out of the side of the function block. You right click on it, say insert assignment, and we'll call it reset system. Reset sys. And that's a work variable that I've already created before this, but it's just an internal variable. If you put a name in there, let's do a different name just to show what happens. We'll just call it reset sys 01. And then I'm going to hit enter. It's not a variable that exists already. I'll hit enter and it just comes up and asks me, do I want to make it an internal or a global? I'll just make it an internal for now. That global is global only to the safety PLC, not to the, it's not global between the safety and the control PLC. And then I'll use that variable down here for this time on function block. So I'll call it reset sys 01, and there it is in the list. And so now whenever either the hardwired reset switch on the safety input turns on or the control PLC turns on its reset, it's going to turn on this reset sys 01 variable, which is going to start our timer for 1 second. And then the output of that timer is going to go into the E-stop function block. And that's down here. Reset delay done from the output of the timer to the input of the function block. Next, I'm going to insert another function, another rung or network below this one. And I want to use this safety output, which I could theoretically or actually monitor in the safety or the control PLC. But just to show an example, I'm going to take this output and I'm going to use it to turn on the exposed variable that we can see in the control PLC. So I'm going to right click in that rung and say insert assignment. This gives me a little structure that lets me have an input that turns on an output. So my input is going to be that safety relay out. And it appears in the list, but the list is cut off because of the screen here. And I would normally be able to click on it down there, but I'll just hit enter. And then what I want that to do is turn on the SPLC bit, which is, I can't remember what it is, so we'll go back to the exposed variables. That was a mistake there. We'll go back to the exposed variables. And it was SPLC E-stop OK. So we'll go back here and say SPLC E-stop OK. And there it shows up. So now we've done the programming side of the safety CPU completely. We're going to go back to the control PLC. Selected that. And we have to go to the I/O map for the control PLC. And what you'll see is if I go to the I/O map and expand on the NX ECC202, that's the coupler that the safety controller is on. You'll see there's the safety controller, the NX SL3300. I'll expose more of that. And you can see here's my SPLC E-stop OK and my CPLC reset. But there's no variables for those. So in order to use these in my program, I have to create variables for them. They could be the same name. If you want to just say, name it this SPLC E-stop OK, that's fine. But we'll just make it easy and call it E-stop OK. And then we've got the CPLC reset. We could call this reset safety circuit. And magically these comments for the variable appeared, but that's only because when I started typing, I had created this variable earlier and it was in the global table, and as I started typing it selected it from the global table. So when you're creating variables in this table, you can actually create new ones here, or you can select variables that you've already created in the global variable table. Okay, so now we're going to go to the PLC programming section. Let me collapse this bit at the top, the configuration info, so you can see the PLC programming part better. And I'll double click on that program. And then we'll see the ladder editor here. The first thing I want to do is add a rung below the current rung. So I'll say insert below by right clicking in this left column and then highlighting this. Or you could do an R, that'll put it below. Insert rung below. And then let's say that I'm going to hit C to add a normally open contact. Let's say there's a bit on my HMI screen that allows me to reset the circuit. So if the operator's looking at the screen and the safety circuit needs to be reset, he can push that button. Or if they're standing near the button that's near the E-stop, they can push that physical button. So we got two, either way here. This one's controlled by the PLC, so the control PLC. So we'll go HMI E-stop, HMI reset E-stop. So I've already created this variable. It's in my global table. That's why it shows up here. If I hadn't created it, it would be created at this time when I type it in for this instruction. So once I've got that in, I'll hit enter and then just click here on the right of that contact, and I'm going to type the letter O on my keyboard, and that puts an output in. And I want to have this HMI bit reset the exposed variable. So in order to know what that exposed variable is, I want to go back to my I/O map, and I'll pull down that ECC202, NX ECC202 to see the NXSL 3300. Expose more of those, and that bit is here. The CPLC reset is called reset safety circuit. So now I'll go back to my program and I'll make that the variable here, reset safety circuit. There's that. And then I'm going to create another rung, insert a rung below. I'll do C again to make a contact, and let's say that I want to use that bit that tells us that the E-stop system is okay, so it's called E-stop OK. And I'll, whoops, that's the wrong one. Go here and say E-stop is okay. So that's a status bit coming back from the safety PLC. And then I'll click O again to put an output, and this could be HMI E-stop OK. So now when the E-stop is okay in the safety PLC, the E-stop circuit's okay, it's going to turn on this bit, which would then make a lamp or an object change on an HMI. I could use this bit here directly on the HMI, but I wanted to prove a point of how we just use these variables in our ladder programming. So once we've got this done, we can download to the PLC and to the safety PLC, and then we can test it. There's a few steps we need to go through to test this. I'll outline them here, but you're going to download the program to this control PLC, then you're going to go over and transfer the program to the control PLC by going into debug mode, and then after you're in debug mode, you have to validate the project and set it up. I'm going to go through those steps fairly fast so that we can see the test, because in another video I'm going to spend more time on the validation process of the safety PLC. So first thing we need to do is go online by clicking that yellow triangle up there, and we've done that a bunch of times already in the past. And now I'm online with both the safety PLC and the control PLC. But since I'm looking at the program for the control PLC, when I go to download, that's the controller I'm going to download to. So I'll go controller. I'm sorry, I won't do that. I'll go synchronize by clicking on the synchronize button. It's building the project, and you can see the status there, and then it's going to do a comparison. So in this case, the result of the comparison is that nothing has changed, because when I was preparing for this demo, I actually already downloaded this project to the safety or the control PLC. But normally you'd say transfer to controller, and then it would go through that process and come back and tell you that it's done. So I'll close that. Next, I'm going to go to the safety PLC. And just to make sure we know we're looking at the safety PLC, I will open up the program for it, because we're going to need to see that anyway. And then I'm going to go to the project menu, or sorry, the control menu, and I want to change the mode to debug mode. You may not have seen as many options or many questions as I just did. It's because my PLC was actually running this in a validated running mode for the safety controller, and I took it out of that. If you haven't ever had it in that mode before, then you won't have as many questions to answer. But I'm going to take the debug, and I'm going to start it. And now we're started. The program's actually running, but it's in debug mode. If I click on my reset switch, you can see that we're monitoring that stuff. I just have a box with the, well, you can't see it. Don't look over here. Now that that's done, but if I go back to my PLC program, see, I've got this guy turned on. Sorry, I can turn this on, and I don't think we'll see it over here. Oh, we will. You won't see it in your program until you've actually gone through the whole validation process that I'm going to go through. If this is the first time you're using your safety PLC and you have never validated your project, when you go to turn on the bits over in the control PLC, you won't see them come on in the safety PLC until you've validated and downloaded your project. So we'll go through that process now. We'll go to the project, controller, and we'll do safety validation. And it just is saying, hey, you're about to validate this, which could stop the program on the safety PLC. Like I said, I'm going to come back to this in another video, and we'll see the whole process in a little more detail. And then I'm going to take the controller and put it into run mode. And so now this is actually running the program as if we were deploying the machine. So this, if I powered down and powered back up again, this controller would stay in run mode, or would start up in run mode. So now if I go over here, see, here's our CPLC reset. If I go back over here and turn that on, turn on this HMI bit, turns on that bit, and then if I go back over to the safety PLC program, you can see that that bit's on in the safety PLC program. And in fact, you may have been able to hear it, but it reset the safety circuit, and the safety relay turned on. So you can see that there. I can hit the E-stop, and we'll see that the E-stop is false now, so that safety relay output turned off. Might have heard it. Now I've reset the E-stop so it's true, but we're not resetting, even though this is true, because it has to transition from false to true. So I've got to go back over to my control PLC, turn this off, and then I can turn it back on, and for real quiet you might hear that relay kick in. And so now if we go back, you can see that the E-stop circuit is reset and the safety output is true. So that's how we expose variables and use them in the control PLC to exchange information with the safety PLC.